All right, guys, just another minute here. Just letting everyone take their time to get to the stream. Okay. Okay. Cool. So, guys, welcome back. It's 12:45 now, so just going to get us started. Thanks so much for being in the meeting and attending. It's always nice to be back with you guys. I know we've had a little bit of a longer gap between the last time we had a live stream and today. That's because last Thursday's Veterans Day, obviously, and then Tuesday of last week, by design, was a day that you were supposed to just watch videos that I shared through Canvas about media literacy, advertising, marketing, and the media. So a couple things I would like to say before we start on today's lecture, just to kind of give you updates on the schedule. Nothing different, just reminders about the layout of the calendar. So this week we have two meetings that are both on chapter 12. So we're going to start talking about science. That's the topic of chapter 12. So there's a lecture on it today, and then one on Thursday, and then next Tuesday, a week from today, that's when we will have the quiz on chapter 12. So that's the third quiz. That's going to just be on only chapter 12 in science. So you want to, of course, view these lectures, take good notes, read the textbook, and you should be good and prepared for the upcoming quiz next week on Tuesday. Now, next Thursday is obviously Thanksgiving, so that'll be a break for us. And then we'll be back on the following Tuesday afterwards. I have assigned to you guys the third homework assignment. And so just want to make sure that you don't forget about that. I edited the due date that was listed in the original syllabus, so I modified it to give you more time. And the third homework assignment, I know I've sent you the instructions through Canvas, so you can always go back to the original announcement to see these details. But since we haven't been able to talk about it in class yet in the live stream, I just thought I would talk to you about it. So anytime before Sunday, November 28th, midnight, so before the end of the day of that Thanksgiving weekend, you have to just send me your third homework assignment. And the third homework assignment is basically where you're going to try to find examples of fallacies in advertising, marketing, and the media. So like if you can find commercials, whether they are print ads, televised ads, internet ads that you're able to find links to, however you're able to collect them and compile them, I need you to send me a file that contains all the examples of fallacies that you were able to discover. And you have to also give a one-sentence explanation as to why that fallacy was the one you thought was in the example. You're trying to find all 20 of the examples from our textbook that we learned about. And if you get all 20, you'll get your full credit for this third homework assignment. So in the past, when I was teaching this face-to-face, I had the assignment designed where students would all come in and bring in a physical magazine, and then they would work in small groups trying to find examples of fallacious advertisements in the magazines. They would cut them out and compile them and hand them to me that way. Since we're not doing, in-class meetings, it's an individual assignment now, but you also have more time to do it. In the in-class format, it's just one class period, but it was a group work activity. So I just want you to feel like creative and flexible in the type of materials that you're allowed to use. I'm going to construe the idea of an advertisement or a marketing impression pretty broadly, so you can, try your best to find the best examples out there. I do think that a lot of them are easy to find in printed materials. Like, so if you have, like, say, fashion magazines with the full color, glossy, full page ads, like Cosmopolitan and stuff like that, they've got a lot of these fallacies that are easy to find in some of those types of magazines. But, scour the earth for whatever sources you can find. You can find advertisements in physical space. You can sometimes find them in printed materials. Sometimes they'll be in video commercials, and in other cases, something in between. Gabriel, you're a bit confused how ads can have fallacies. I don't think ads are really a rational thing. They work by taking advantage of your emotions and lizard brain. Well, I mean, Gabriel, it's just been a commonly discussed concept. I don't know if you watched any of these videos that I actually sent around, but like, say, in one of them, like the last video in the link series, it's a compilation of advertisements produced for Axe body odor control, deodorant stuff, and they have like a list of different fallacies in them. That's kind of fun and just kind of humorous. And then also in the other videos that I linked you to by the guy Jay Smooth, who does the Crash Course Learning Net web series, and he did the thing on digital and media literacy. One of the episodes, I think, Influence and Persuasion, or maybe the darker side of media, they talked about fallacies in ads, and he gave some examples and some discussion there. Yeah, so I understand that you're saying if you watch an Axe ad and think their ad is trying to convince people using their product will literally flock to you, you're missing the point. Yeah, I know, but the whole point is that they don't work on the basis of rational persuasion. Fallacies are not rational. Fallacies are bad arguments. They're invalid. They're not relying on relevant evidence, or they are relying on unjustified assumptions. So your claim is correct. I mean, yes, fallacies make the argument invalid and not based on good reasoning. So what you're learning and what you're being taught is that a lot of marketing impressions are not based on good arguments, but are instead clever attempts to trick, deceive, manipulate your viewpoint into buying the product. And the better able you are to see that, then perhaps the less easily manipulated or subject to these market forces you will be as a consumer, and the more wise you will be, not just in consumer habits, but also in political arguments, advertisements for ideologies, perspectives, worldviews. Yeah, so I mean, there's got to be a way for you to find these examples, and I know you can because it's been a successful assignment for a lot of different students. You don't think there's an argument being made? Well, they are trying to persuade. And every advertisement is an argument of a kind, because it doesn't have to be a good argument to be an argument. A bad argument is still an argument. Anything that says, therefore, you should buy this product is trying to make some appeal to your interests, at least, or some appeal to you as to why you might want it. So they say, here's some kind of need that you have. Our product answers to this need. And therefore, in a perfect world, we can see that there's some attempt to convince you of something. So whether that's a good argument or not is up to the individual example. Sometimes I guess advertisements can contain factual information. I don't know, like if you watch an advertisement that just describes the virtues of the product and the conditions under which you might need it, then that could be a rational based argument. But I find that a lot of times, because of the zeal that they have to make profit off of us, they do deviate from high standards of good reason and critical thinking. And that's something that's been discussed in almost all the classes that teach this kind of material. So it's kind of a common trope of a critical thinking class to look at some of these things. But guys, just know it's due on Sunday, the November 28th, anytime before midnight. And if you need any help or guidance as you're doing it, please feel free to contact me. Some of you have, but it seems like you're doing fine with it for the moment. Anyway, though, do keep in mind that you have to use different fallacies. You can't like find 20 examples of the naturalistic fallacy or something. That'd make it very easy. So you have to try and find a different fallacy. When you have one, it's on to the next, and trying to get all 20. Okay, so I hope that's now clear. Just a little bit of a reminder to do your third homework assignment, and it's due November 28th or before, whenever you have it ready, you can send it to me. And the quiz that's next Tuesday. After those two things, we're really just down to the last few items. There's going to be a fourth homework assignment that I'll assign to you after we get back from our Thanksgiving holiday. And then there's the final exam itself. So we're getting closer to the end, but we've been doing well. Okay, then, so if that's all clear to everybody, then I'm just going to go ahead and start building up our notes on chapter 12. So chapter 12 is all about science. And in the beginning of some of our other chapters, you may have noticed that they kind of sometimes begin with some anecdote or citation of a real world event or phenomenon to try and bring the reader's interest into the topic a little bit more. And Thanks, Kyle, for mentioning that you're here. I guess I should say to everybody that is present, if you haven't yet had a chance, go ahead and leave a comment in the chat. That'll be a way of just keeping track of attendance. You can leave it in either chat, whichever one you prefer to use. I'm using the dual stream format as I have a few times. So some people watch on YouTube, some on Zoom, maybe some on both. But anyway, thanks for your attendance, and just let me have a comment if you can. Okay. So in the beginning of chapter 1, they chose to refer to those famous social psychology experiments, Milgram and Zimbardo, to kind of highlight the importance of being a good critical thinker. In the beginning of chapter 3, the one on language, it was all about the Benghazi scandal and how miscommunication maybe facilitated a shortage of preparation for evacuated casualties when our diplomatic embassy got breached in Libya. In chapter 4, they talked about famous cases of medical error, like horrifying cases of medical error, like amputating the wrong leg of a person scheduled for surgery. And that was supposed to remind us of how cognitive errors and perceptual mistakes can sometimes lead to jumping to the wrong conclusions, even to people in positions of great responsibility. So it highlights the value of knowledge and all of that. Chapter 5, fallacies. We talked about the case of Shannon Townsend, who got manipulated into joining a cult based on poor arguments that she was not able to determine as fallacies. And so it kind of reminds us to be wise to the way of fallacious argument and how it can manipulate us if we're not. And now we're at chapter 12. So chapter 12 is about science, and it starts off by just mentioning the case of global warming and what we know about global warming and what maybe it portends for the future. So it's a significant problem, which is causing sea levels to increase because of melting Arctic ice and the ice shelf. Basically, fossil fuel use creates carbon emissions that get trapped in the Earth's atmosphere, producing what's sometimes called a greenhouse effect. This, over time, causes a gradual heating of the Earth's surface. And so the trapped carbon emissions in the Earth's surface that cause the greenhouse effect lead to increased melting Arctic sea ice, which is causing sea levels to rise globally at a significant rate, much more so than we saw over the whole prior century. And it's kind of it's a concerning issue because it seems that the heating trend has actually accelerated a lot just in the past 20 years since the turn of the century, and especially even in the last 10 years. It's a shocking but true fact that the hottest 5 years ever recorded since we started keeping measurable temperature data in 1850, the hottest 5 years on record have all happened just since 2010. So you guys are living in the hottest times that have ever been recorded in human history. And January 2019, for example, as the book says, with its widespread droughts, deadly heat waves, and massive storms, January 2019 was the hottest January on record in the continental United States. Now, what could happen if we can't get this problem mitigated at least, or best case scenario, under control? Well, according to certain models that predict the effect of global temperature increase of another few degrees, we could see as much as a foot or more of additional sea level increase before the turn of this century. There's actually a big climate conference going on right now internationally in Copenhagen, Denmark, the COP26 summit, where we're trying to get international parties to agree to some framework where we can possibly limit the global increase of temperature to less than 2.5 degrees, which is already a dangerous number, but it's possible that it could be even more than that with devastating effects. And you're right, Sky, there are other ecological impacts from climate change, not just related to the rising sea levels. But I mentioned that because the book does. And after all, we living in a coastal region have a lot to be concerned about, because by the time some of you guys are retiring, if these certain models turned out to be true, then we could see significant erosion of the coastal areas, wetlands, and even maybe in some cases submersion by water. So the thing is, we have to therefore be able to, as critical thinkers, interpret and evaluate scientific information that we hear in all different forums, whether it's in media, in scientific journals, through academic journals, or through word of mouth. So in this chapter, as we examine science, we'll learn a little bit about the nature of science itself, the history of science, who are some important figures in the early Western history of science. We'll identify what are some fundamental assumptions that science makes. We'll talk about the scientific method and the steps that it has. We'll talk about the difference between real quality science and pseudoscience, which is like false or fake science, basically. We'll also talk about the relationship between science and religion, which is interesting too. Um, yes, and greenhouse gases are also released when the ice melts, further exacerbating the problem. So there's definitely issues here that have to be dealt with. It's also causing other problems, it's causing more intense weather cycles, extreme heat and cold, worse hurricanes, um, and this is also having impacts on different life forms, and some species are becoming extinct. So there's a cluster of problems brought about by these facts, but it's the scientists and the scientific community who we can rely on to inform us about this information, and also to try and work towards some type of possible solutions, or at least mitigation. So let's start then with the first big topic of definition in chapter 12, which is simply what science is. Obviously, we want to set the stage for the chapter. So what is science? As the book puts it, it's this: science is a process of reasoning from observable facts to testable explanations for those facts. So here I'll write it. Okay, here you see a sort of brief definition of what science is. Reasoning from observable facts to testable explanations for those facts. So with science, you start through observation of the world and what happens. And so you just kind of collect data and you notice phenomena that occur. But with science, we don't just want to like observe something happening and leave it at that, like, wow, a volcano went off, cool. We want to observe it, yes, but we want to eventually be able to create or to generate an explanation for the fact, like why does it happen or what causes it to happen. It's only by knowing why something happens or what causes it that you can control the kind of event that it is, or that you can plan for it so that you know what kind of factors lead to its occurrence. So in the end, the goal of science is explanations. We want to have explanations for the things that are happening. So for example, why did the volcano erupt? Why is electricity coming from the sky when lightning strikes? Why does the plant grow? Or why does the sun provide heat? How does light propagate in space? How, for example, do geothermal processes produce heat on the Earth's surface? So in every single case where we have a why question, science is what's trying to give us an answer. So we start by observing the world, noticing the things that are occurring, and through a process of scientific reasoning, we eventually hope to get a hypothesis that correctly explains the facts and why they happened. So science is the major source and method for discovering anything about the world around you. If there's something that you want to know about this world or how it works, or about this universe and how it works, why it happens, then science would be your best resource to turn to for an explanation. If you want to know, why the sun goes up, why the moon is orbiting the planet Earth, why hurricanes happen, tornadoes, earthquakes, or anything else, it would be a scientific answer that would give you the most realistic and evidentially based answer. So we actually, I think, have to have a heavy dose of respect for science. Sometimes people don't like science, and I think it's because sometimes they're scared by the things that it says, because it makes them think that their position in the world is tenuous, or that we're not as special as we think we are, or something like that. But the thing is, without science, our lives would be so much worse. I hope everybody understands that. Right now, we live in a modern world with so much great technology, and the trappings of modernism make our lives much better than it ever was for our ancestors, who lived agrarian lives and basically had to subsist on the land and live as farmers. No problem with that, but it's much nicer, isn't it, to live in a world where you have all these options for communication, like we're having right now, or transportation, or technological innovations that allow us to entertain ourselves. So science is the reason that we have these things. They don't just exist by chance or by magic. It's through the scientific method and the process of developing technology. So all of us living in the modern world, enjoying these nice new things, have to have some degree of respect for science, because it's not by accident that the world that science has built is the one that we're living in. Now, when we talk about the history of science in the West, there's a couple of important key figures that are sometimes mentioned, which the book mentions, so I'm going to talk about them too. The first one to speak on is Well, there are a lot of existential problems, sure enough, Gabriel. But don't you think that it's nice to have like effective medical treatments, surgical procedures, connecting with people all over the world, um, also being able to remediate problems like you have glasses if your vision is bad, or I don't know. I mean, it's a lot of convenience, isn't it? But surely you could argue that we've maybe had a sort of a spiritual loss of connection to the natural world. Maybe that's something fair to say. But speaking to an audience of fellow, Westerners living in our part of the world, I think I'm speaking to those that probably do value our status quo, at least in some ways. But anyway, it's a fair philosophical question to ask. Um, yes, thanks. I'm glad to hear that your dad's doing better, and so good. I know you guys had a tough time with that incident. So anyways, good to hear that. But let's go on. I want to talk to you guys about a famous individual in the early history of Western science. So this is Nicholas Copernicus. And he lived from 1473 to 1543. And his major contribution, which is really important, is that he discovered what is known as this heliocentric model of the solar system. Okay, so really fast here, just typing out facts about Copernicus. Okay, so Copernicus, he discovered the heliocentric model of the solar system, and that replaced the older geocentric model. Now, I guess some of you guys know already about this concept, but what is the heliocentric model, if you know, or if you have a wise guess? It is the model in which all the planets revolve around the sun. So the sun is at the center, is what it means. Helio is a reference to the sun. Centric means in the center or in the middle. So heliocentric, sun-centered model of our local cosmos. Now, Copernicus was able to use more powerful telescopes that were coming into use in his lifetime to conduct more precise observations of the motions of the celestial orbs and the celestial bodies. And he was able to discover, based on this empirical observation, that it is the sun which lies at the center, and we and the other planets rotate in an elliptical orbit around it. Now, does anybody know what the geocentric model was that this replaced? Yes, correct. The geocentric model says that the Earth is in the center of the local cosmos, and all the things revolve around us. Geo meaning Earth, centric, centered, so Earth-centered model. Now, it may not seem like a very big deal to us today because we just think it's a given. Yeah, of course the sun is at the center, and we're the third planet from the sun behind, Mercury and Venus, and then after us, Mars. But this was actually a very radical and revolutionary development in the history of the West, because prior to Copernicus, right, it is the solar system, reference to the sun. That's why sometimes I say the local cosmos, so that I don't confuse you by saying the geocentric model of the solar system. But anyway, yes, prior to Copernicus, the dominant view in the West was geocentrism. And some of the ideas about geocentrism can be traced back to this man named Ptolemy. Yes, I'm going to talk about Galileo as well. Ptolemy is like a 2nd century Egyptian astronomer who thought that the Earth was at the center of the cosmos, and that view was considered very important because it was tied to the orthodoxy of the church. Okay, so the church was like the dominant institution in the West all the way up through the medieval era. Some people call those the Middle Ages or even the Dark Ages, to indicate that a lot of knowledge was suppressed by the theological power structure. And so what the church believed, and as you're saying correctly there, Kay, was that God is the author of this universe. And if he did make it for the sake of man, we're created in his image, right? We're the children of God. They thought that he would have wanted the earth to have a central position. We should have pride of place because we're the point and the reason that the whole universe exists, according to the creationist claim. So they really held fast to the idea that God would not have wanted us to be in a random, non-central position, just like another one of the planets. Um, and there were also other reasons that were adduced by classical thinkers way back in the day, thousands of years ago. Like some of them, Aristotle, for example, believed that if the Earth was moving, then if you jumped, for example, then the Earth would slide out from underneath you as it continued to move while you jumped in the air. But that was wrong, because while you're on the surface of the Earth, you're moving with it as the same frame of reference. For the same reason, if you like flip a coin in a car while you're driving, it's not like the coin flies back and hits the back windshield or the back window because the car slides underneath it, because it's sharing the same velocity of motion in the frame of reference that the car is. So it moves forward with the car. Um, they also believed that if the Earth was moving, then it wouldn't feel like you're standing still, because when you're just standing on the surface of the Earth, it seems to be solid and it seems like it's unmoving. They thought there might be wind resistance constantly by the Earth's trajectory through space if it was actually passing through space instead of just standing still. But anyway, those views were learned to be false by Copernicus's discoveries, and also Galileo, another important scientist and astronomer that lived in around the same time as Copernicus. Now, Galileo, the church was really tough on him, actually. So they asked him, because they knew his work, he was publishing his findings about the heliocentric model. And they found this to be so offensive to the religious doctrine that they forced him to go out in public and publicly recant his testimony, meaning that he had to go in front of everybody and say stuff like this: "Hey, everybody, sorry, I don't know what I was thinking. Maybe I got possessed by the devil or something, but I was just kidding about, the sun being at the middle. That's wrong. And I don't know what I was thinking, but it's really the Earth." And he was forced to do this under penalty of death because they were threatening him with execution if he didn't retract his findings. He was 70 years old, though. I mean, that's pretty rough on an old guy. He was half blind because he'd been looking at the sun through telescopes too much. So that was pretty tough for him. But in the centuries that have passed since then, the Christian church has officially apologized to Galileo and his descendants, because there's no longer any debate on this. There's no controversy at all. Nowadays, we have extremely powerful satellites and telescopes, which can literally just take pictures of the celestial organization of the different planets. And we know for a fact that the sun is at the center. But it's just an interesting development, because it really did, some people call it the Copernican revolution, this discovery that he had, because it kind of opened the door to the idea that through observation, we can actually discover truths that have been in some ways repressed by religious orthodoxy. And so that kind of jumpstarts and sparks a scientific revolution where people feel more and more comfortable going forward of doing their own research based on empirical evidence. And Gabriel, the coin would shoot back if the car was accelerating. The Earth is indeed accelerating since it is going in a circle. Well, yeah, if we started the acceleration, fair enough. But if you're in constant motion, then that's different. So that's the difference between the general and special theory of relativity. In general, objects just move in a given path with a given velocity. But once they change that velocity, then we have acceleration. And that's when you start to see these forces behave differently. Oh, not to worry. Hi there, James. Good to see you too. Okay, so we continue from there. Another important figure in the early history of science in the West is Sir Francis Bacon. And he lived from, let's see here, 1561 to 1626. And Sir Francis Bacon's main contribution to the world is the scientific method. Yeah, so he formulated the steps of the scientific method. Yeah, it's just about constant velocity. That is the difference between a thing that's in an accelerating state and in a sort of general state of motion. Yeah, Sir Francis Bacon, everybody, he formulated the steps of the scientific method, and that scientific method is like the bedrock formula for conducting scientific work or research. Basically, we're going to talk about the steps in more full detail on Thursday, because I've saved that for the second lecture here. But you basically start by observing the world, identifying some phenomena that you want to explain. Then you try and generate a hypothesis to explain why it happens. But then after the hypothesis has been generated, you try and test it. You create an experiment by which you can see if the hypothesis is verified or disconfirmed. And if it's verified by the experimental results, then you would publish the findings to see if others can replicate them. If not, if the experiment disconfirms or does not verify the hypothesis, then you've got to go back and create a different hypothesis and continue the steps until you get a match between the predicted results of the hypothesis and the results of the actual experiment. We, again, owe a lot of, I think, gratitude to Sir Francis Bacon, because this method is straightforward and simple as it may seem, and as intuitive as it may seem. It's really the linchpin that's been able to generate so much important medical, scientific, technological knowledge. So that's Bacon's contribution. Madeline, you talking about Ptolemy? Well, he's not really mentioned in the book. So I didn't provide a bunch of facts about his dates, but if I wanted to, I could just quickly search him, Google search. I think it's like the 2nd century. I'll give you something really fast on him. At least some dates. No, it's okay. That's a good thing to say. So he was born in 100 AD and he lived to 170 AD. Yeah. So since you asked, I'm just going to let you know that these are the dates of his life. And I mean, he's not in a way, he's a sort of forgotten figure only because his views have been completely, thoroughly discredited by future discoveries. But I'll say one more thing about Ptolemy, I guess, before I move on. To support the hypothesis that the Earth is at the center, and to make that consistent with the observations that he could conduct of the orbit of the motions of the other celestial bodies, he had to assume that the other orbital motions are moving in epicycles. Okay, so epicycles are these weird, like curly Q corkscrew patterns, like that. And the only assumption that would make sense, consistent with the observations that were being made, the only assumption that would make sense consistent with the assumption that the Earth's at the center, is that the other planets and objects are moving in these screwy epicycles. Now, of course, we know that's not true nowadays through the work of Kepler, and then also just based on the tools of observation we've built. We know that all objects orbit each other in space on a smooth elliptical path, not in these corkscrew epicycles. So that's just another aspect of the Ptolemaic view of the universe. Okay, yeah, there you go. That's a good one, Sky. Your kids will have to learn on their own, I guess, what the facts are. But okay, so we're good on that. The next thing I'm going to talk to you about are some assumptions that are behind science. So built into the practice of science, there are certain given assumptions that we would like to know about. Okay, so let's try and find out what are some of these so-called assumptions behind science. The first one is one that we've actually talked about earlier in the class, so it's coming back again, and it's the concept of empiricism. That is one base assumption of science, empiricism. Now, I'm going to write the definition, but I wonder if anyone could remember. Empiricism is the belief that most human knowledge is coming from something, but from where? Yes, the senses, the 5 senses and observations. So that's right. Okay, so this is a concept that's appeared twice, at least in our class. Once when we studied chapter 4 on knowledge, and now again in chapter 12 on science. And yeah, science does assume that most of our knowledge does derive from the things that we can observe using our 5 senses, or by means of instruments that we build to enhance the power of perception, like telescopes, microscopes, stethoscopes, or whatever. Science fundamentally proceeds from observation of the world. And so, of course, it assumes that you can get to truth and knowledge from the starting point of observation. If we didn't think that was possible, then science wouldn't work, because it's all about collecting data through observation and then trying to formulate hypotheses to explain the things that you've observed. So If we were powerless to gain knowledge from our five senses and observation, then we would have to say science is just a big guessing game. But science assumes that it's not. That real knowledge can and does come from the five senses and observation. Now, mathematics and logic are also a part of what science uses as tools, and that's a little more rationalistic because those aren't derived from sensory perception. But the bulk of scientific investigation and inquiry does start from the things observed. So empiricism is a core assumption, founding assumption of science. Another major assumption of science to add is what's called objectivity. Okay, so this is a key idea. It is the belief that we can learn about the universe as it really is, not just as it appears to be, but that we can learn about the objective world, in other words, as it really is, and that we can do so with no bias. So let me write that down. Okay, so I'm putting a little accent or emphasis on the word really there because that is one of the key terms within the stated definition. It's the belief that we can learn about this universe as it really is, and we can learn about it with no bias. Now, the concept of objectivity is often contrasted with subjectivity, or we could say that the objective is oftentimes contrasted with the subjective. So I want to make this clear to us through some examples or questions. So if I tell you, Gabriel, what you say is, how can that be true if everything we see goes through the filter and is processed by our emotional, irrational brains? Yeah, that's why it is a sort of assumption, I guess. What scientists believe is that despite the forces of, our emotions, our desires, our biases that we sometimes have, that within scientific practice, we can set those aside, operate according to standards and methodologies that are objective for finding facts and truth, and that we can discover the reality behind the things that we appear to see. It's an assumption, I guess. And so if you have a skepticism about it, like Descartes or something, like, hey, who even knows if the external world is real? Then you might say, I don't know if I can buy into the assumption. But science is, in that sense, maybe a little less skeptical-minded than some philosophers. They do believe that we are in the midst of a real objective world, which has a set of objective facts waiting to be discovered by the rational mind, and that the rational mind can, in some way, build a bridge between its own subjective point of view and then the objective reality that it is immersed within. So, I mean, you ask, how can that be? And I don't know, it might just be an assumption that it's possible. But it's an assumption that we have to have, or else we can't even say that we're going to be able to do science. And certainly with the success of science in developing a lot of technologies and so forth, as we've said earlier, I think that there's some good, reasonable evidence then that we do get to the correct objective understanding of reality. But I was going to say something about the difference between objective and subjective really quick, guys. So let me make this point. If I tell you that vanilla is the best ice cream, is that an objective or a subjective statement? It's subjective, that's right. And why, though, Armand? That's the right answer, but can you give me a window into your reasoning? Why do you say it's subjective to say that vanilla is the best ice cream? Yes, subjective, but I'm just looking for a follow-up question here. Why? Why is it subjective? Really? I don't think it's that hard to say. Maybe someone else can take up the task. Anybody? You say it refers to personal preference. Yes, that's correct. And you say the same, Josh. It's just my own opinion. That's right. So it's not like we can say it's an objective fact that this is the best ice cream flavor. That is a matter of taste. That's a matter of my own individual perspective on it. If somebody else doesn't agree to that and they say, no, I think it's chocolate, I can't tell them, no, you're wrong. That's just objectively not the best flavor. So it's a point of view. It's a perspective. It's based on my individual view. But what if I tell you the Earth is the third planet from the sun? Is this objective or subjective? It's subjective, right? Because it's not just, it doesn't matter if I believe it or not. It's not up to my opinion. It's just a fact. It's an objective fact about the universe that is where we stand in relationship to the star that we're orbiting. So in science, we believe, scientists in the scientific community assumes anyway, that we can get to the objective truth about reality, and that we're not just all talking about our feelings, our internal associations, or our subjective points of view. That science is not just a subjective activity of throwing out personal opinions and feelings, but that rather there's objective facts, they can be discovered, and the power of the mind can get there using the scientific method. If we didn't think that there was objective truth to be discovered, then what would be the point of doing science? You would just be learning about people's opinions and not about real truth. So if you have skepticism that that's possible, that's fine. But the scientific community anyway assumes that it's possible to get to the truth. And when I think about the fact that atomic bombs, are based on principles of atomic physics and they actually work, or that a microwave is based on knowledge derived from facts about the electromagnetic spectrum, and then they actually work, that gives me a sense of credibility in the assumption of objectivity. Other comments here. Josh, can there be objective truths found by things outside the realm of science? Perhaps there can be. Yeah, I would say so. I mean, some people might say that there is an existing God and that can be determined by rational argument rather than by scientific inquiry. And if you believe that this is true, then that's a possibility right there. Rational or conceptual arguments can sometimes be given to try and prove things that are not based on the scientific method. So I would argue that it's possible, but the best source and method for gaining access to facts about the truth and reality is usually science. But I guess I couldn't say categorically that there's no realm for like introspection or intuition to discover objective facts too. But I guess that's a bit of a philosophical digression. It's take a little while to explain how it's possible to have knowledge without scientific inquiry. But like, for example, you know that you exist, and that's something that's known by immediate intuition because you're thinking, and it's an objective fact that you exist. So that could be one example right there. Gabriel, you say, Josh, you can always guess and be right, but science is like guessing but better. Yeah, that's kind of what I was thinking too. When I say intuition, though, it might be something better than a guess because it could be somehow supported by rational considerations. Like, for example, okay, let me tell you this. You can know that the sides of a square are of equal length just by thinking about the abstract idea of the square without necessarily having to conduct any empirical observation of anything at all. So rational insight can be discovered without just guessing, merely based on conceptual truths about abstract objects or concepts like number, figure, shape, and things of that kind. So interesting and cool follow-up discussion. Okay, so we've talked about objectivity. That's another assumption that's found within science. Let's go on to the next of predictability. Yeah, Gödel's incompleteness theorem, Gabriel, that really takes us a little far afield for some of our background knowledge in the class. But yes, in the Gödel's incompleteness theorem, we learned that any system, mathematical or formal system, is going to have certain questions that it cannot answer from within the resources of the system itself. And so there will always be like some undecidable statements. And so, I mean, I don't know if that implies that there's no ability to obtain objective truth. So I couldn't necessarily draw a direct connection between the point about objectivity and the Gödel's incompleteness theorem results. I think sometimes people take the results of Gödel's incompleteness theorem and fashion philosophical theories that are not necessarily licensed by the work itself. But again, that's a bit of a more academic discussion than we need to have just for the moment, but it's a very good thought. And I do have conversations with people who make similar points on that topic. What is predictability? Let us learn. Predictability is the assumption that the universe is orderly and predictable. So, established cause and effect relationships will be repeatable and will hold forever. Scientific assumption of predictability. Um, you see it there. It is the assumption that the universe is orderly and predictable, so established cause-effect relationships will be repeatable and hold forever. Now, I'm sorry for the fact that predictable is a part of the definition. I know that's circular, but I'm just using the material in the book. So, but it can be explained. So here's the idea. In science, it is assumed that once we understand um, a given causal relationship in the universe, that the forces and the laws that govern the behavior of those relations will always stay the same and will never change as long as we reproduce the same physical conditions again. So, orderly can best be explained, Gabriel, by means of examples. So, consider this example. I have this marker right here that I'm holding, and you can see that. And all I'm telling you right now is that I'm going to release it from my hand. Once I release my grasp, what would you predict happens? That's a simple question. You say it falls. Okay. Now, bear with me as I ask you some annoying follow-up questions. How do you know it's going to fall? Like, I haven't done this yet. So what evidence do you have? You say gravity, but I'm still not going to let it go. You say gravity, but how do you know gravity is going to work today? Gravity always happened in the past. So up till now, yes, when you release objects from a freestanding height, they fall. But what makes you so sure that gravity is not just going to stop working today? And going forward, there's no more gravity. You know? Like, what makes you so confident that gravity is not going to stop? You say, I see no reason to assume otherwise. Armand, I like your contribution. It's an inductive-based reason. And getting into the deep details of this, what you're basically saying is, because in the past, it's never been different, right? Well, even if it is objective, James, what if the objective fact is that it works until November 16th, and then right at 1:31 p.m. it stops, and things that are released just float off into the sky, or they turn into a chicken and just walk away or something. Now, you would assume, uh, well, yeah, I know, Sky, but we're talking about the future. It hasn't happened. The future's not happened yet. By definition, the future's yet to be. So, how can you guarantee that the laws of physics and gravity that you've assumed would always operate are going to continue to operate? All you can say to me is because they've always done it before. All the way up till this point, there's never been any change on that. And so that's what the scientific assumption is all about too. We assume that these laws of nature, like gravity, entropy, inertia, the laws of thermodynamics, et cetera, that they operate in a reliable fashion such that they are permanent and they're not temporary. They're not just for here and now, but that this marker, let's see what happens. Just as predicted, it did drop. Now, what if I had infinite time? That'd be a great thing, wouldn't it, if it just had all the time in the universe that I could continue to drop this for all eternity. Would it keep falling forever? We assume yes. That's the point. We assume that the universe is not unpredictable. So it's not going to surprise you by deviating from its natural and physical laws. Can that be proven? Absolutely not, because we don't know yet what is in the future. We can only speculate about it or make reasonable predictions, I should say, based on the evidence collected from the past. So that's like induction. We think it will continue to happen this way because it's never done otherwise. But as much as that's a safe assumption that I'm sure all of us have, it is yet still an assumption because proof would only be possible if you had access to the full future, witnessing on your own the law of gravity never deviating from its course. So science, anyway, just allows us to help ourselves to the assumption that physical forces like those operate the same way, not just for here and now, but for all times and places where the same conditions are generated. So if there was another medium-sized planet like ours somewhere in the universe where beings had the ability to drop an object from a standing height, then they should fall not just here, but also there, because we assume that the law of gravity is a general law that propagates and operates the same way at all places in the universe and at all times, not just temporarily in our local part of the cosmos or for the time being while we're here. Doesn't the whole probability in quantum mechanics disprove this? Well, yeah, okay. In quantum theory, there is completely unpredictable behavior of the tiny little fundamental particles, quantum particles. And Heisenberg's uncertainty principle shows that you can't possibly measure the location and the velocity of one of these quantum particles at the same time, because the observer basically creates a change once they observe it and hit it with photons of light. So yes, fair to say, Gabriel, and you have a lot of background knowledge on science, which is a great thing to have. But it is fair to say that at the quantum level, there do seem to be violations of the predictability assumption. But at the macroscopic level of reality, which is the one that we kind of live in, we think that these quantum unpredictabilities wash out. So you've probably heard it said, if you're talking about quantum stuff, that it's theoretically possible that, like, my hand, if I don't know, like, were to touch the filing cabinet over there, that all the particles could swerve at the same exact moment, creating a hole, and I would just put my hand straight through the surface. But that the likelihood of such an event happening is so low that, for all practical purposes, we just say that it's an extreme outlier. And so, if violations of laws of physics are according to those possibilities, they're just unlikely to ever be seen. But no, fair points. Kelvin, what happened if in the future we are predicted to move into Mars? I don't know if gravity can be applied, though. Well, it would. Gravity still works on Mars. We have a Mars rover over there right now, roving around on the surface of Mars, beaming back images and videos. And no, James, I can't say I have heard of that. But now I'll have to do my own research and find out, since you've mentioned it. But yeah, I don't want to take us too far off of the scope of the current notes, but let's all just make sure that we understood what I was saying there. Predictability. It is an assumption about this universe that it's orderly, that it's predictable. So cause and effect relationships, natural laws, and the like are permanent and immutable. It's an assumption because we haven't, of course, experienced the future by definition, but it's a core assumption of science that the laws are stable and permanent. Okay, now one more, or actually, I guess two more. Another one is materialism. So materialism, a scientific assumption of materialism, it's a different concept than the pop culture use of the word. So sometimes people talk about materialism and they mean somebody who's obsessed with their appearance or with possessions. But no, we don't mean materialistic in that sense. Materialism in science is the belief that everything in the universe is made out of matter, physical matter, including even you and us and our consciousness. So let me write that here. It is the belief that okay, there you go. Materialism. Now, I want to just make a quick point here that it's also sometimes called by another name. And honestly, I actually prefer this other name a little bit better because it avoids the false association and the equivocation with the unrelated, non-scientific use of the term. So it's also sometimes called physicalism. I think it's just a more apt terminology to use because it says right there, physical, everything's physical. In other classes where I teach this type of stuff, that's the label used. But for our book, it's materialism, so we'll go with their usage, but just so you know, there's another label also given to the same. So anyway, materialism, the belief that all things in the universe are made out of matter, including us and our consciousness. Now, matter at the fundamental level, anybody know the term that's used often for the tiny little bits of matter, little particles? Let's see, somebody type that one in. The atom, right. I mean, yes, there are subatomic particles that are sometimes discussed in modern physics, but classically speaking, this is the old school word that's been used all the way back to the ancient Greeks, Democritus. Atom literally means in Greek not cuttable, uncuttable. So it's supposed to be the fundamental unit of matter such that it couldn't be further subdivided into something smaller. And now, according to materialism, or if you want physicalism, everything's made out of atoms. 100% of the whole universe is just a bunch of atoms aggregating and accumulating in the void of space according to the laws of physics. And so are you, made out of atoms, according to this view. So if materialism is true, that means that everything is a physical object and there is not even one thing in this universe that's not physical. The interesting thing about that is that it implies that consciousness itself, like your ability right now to hear me, see this, have thoughts, memories, perceptions, feelings, emotions, pleasures, pains, that is all just physical itself. It's a result of brain activity. And so when you have conscious states, that's just a neural state that your brain is in. On the physicalist or materialist view, there is no such thing as a soul, there's no spirit, there's no ghost, because consciousness cannot exist in a disembodied state. It has to have the physical brain functioning in order for it to support the phenomenon of consciousness. So there's no afterlife or heaven or hell according to materialism, because there's no such thing as a non-physical substance that's thinking. There's just brains that have thoughts. And you're just a brain in a body having these thoughts and these experiences, according to materialism. Now, I don't know, some people find that a little depressing because they're like, no, I like the idea of having a soul and being able to exist for all time and have an immortal soul. But anyway, that's not a scientific view. So it's an assumption of science anyway, not of religion necessarily, or maybe not most common folks' beliefs about the sort of metaphysical situation they're in as a human being, but it is a scientific assumption. It has to be mentioned. Reading from the book about it, I'll just go ahead and touch base with the text. You thought Descartes sat down and made the ultimate foundations for understanding. Yeah, but not everybody thinks that the far depths of skepticism that he dives into are necessary for having knowledge. There's a whole tradition in modern day epistemology that says Descartes was wrong to think that skeptical considerations block knowledge. The dominant trend today is what is called externalism. Sometimes it's called reliabilism. And that just implies that as long as you have a reliable connection to the facts of reality, it doesn't matter whether or not you're able to justify them. Just having the reliable connection is enough for you to be someone who has knowledge. So the kind of ability to discharge all objections is not a requirement. All that is required is that you actually are in the physical universe and that you're reliably connected through your sense perception to it. Reliable. Like, for the most part, when you have perceptions, they're truth conducive. That means that they reflect the reality. If it was unreliable, that would be like a perception that turns out to be incorrect for the most part. So as long as you're reliably connected to the facts, then your beliefs are counting as knowledge. That's a difference from Descartes, who thought that skeptical possibilities prevent you from having knowledge. But this is like a deep and vexing issue in epistemology. I would ask you, Gabriel, if you're interested in these questions, take my philosophy of knowledge class in the spring. I'm doing it face-to-face there at Orange Coast, and it's all about knowledge, and it's about these questions. But anyway, yeah, so another assumption of science is materialism, and I'm just going to read from the book about it. Here's what it says. With the doctrine known as materialism, empiricism goes a step farther. Scientific materialists argue that everything in the universe is physical matter, and they mention that it's not the other kind of materialism. Materialism, in this sense, has nothing to do with being obsessed with acquiring money, consumer goods, and other material things. Okay, according to scientific materialism, perceptions, thoughts, and emotions can all be reduced to descriptions of physical systems such as brain waves or stimuli and response. There's no need to bring into scientific descriptions and explanations extraneous non-material concepts. Because of its materialistic roots, science has made little, if any, progress explaining how matter can become conscious, and it is still a mystery of a kind. How is it possible for us to have, how is it possible for us to have thinking matter? If the universe begins, according to the scientific hypothesis, as just a bunch of inanimate matter or, non-living matter, how can that stuff somehow fast forward billions of years and the matter has turned into people having conversations about these topics right now, like us? To some, there's no scientific way to explain that, but science anyway does presume and presuppose that everything's physical and that we live in a physical universe. Therefore, that's a baseline assumption that's a given. Now, are classes going back to face-to-face? Yes, they are. But you look like you're sad, Sky. Is that a sad thing? I think it'll be a good thing because we'll all be able to see each other and interact, as long as everyone's healthy and safe and trying to get vaccinated, of course. But yes, we are going back to face-to-face in the spring. So I have 2 face-to-face classes. This one, another section of this, and then also the epistemology class that I'm talking about. Yeah, it'll be nice to be back fully in person. This is the only institution right now where I'm teaching that's still online. And yeah, I like being out there in the physical class with everybody. But there are some benefits to being online as well. Can't deny that. It just depends, I guess. Some. Okay. So we've talked about materialism. Next, I want to quickly touch with um, unity. Okay, so unity. So one more of these assumptions that are built into science. They call it unity in the book, and what they say is, this is the view, the belief that there is an underlying unity to the universe such that um, everything can eventually be explained according to a single set of scientific laws. Okay, so just pasting that into the two chats here. Okay, yeah. I see what you're saying, Sky. Like, yeah, there's a lot of distractions when you're on the computer and stuff. You know, a lot of times people will just say, "Oh, I'll pay attention later because it's all being recorded," or, I'm gonna open other windows and focus on them while the professor's speaking. So yeah, your attention definitely gets drawn to the class lecture in a physical setting, but you know, I'm sure there's some people that prefer it either way. So back to the unity though. Um, the unity belief is that there's an underlying unification, unity to the universe, but the main point is the second point here, that everything could be eventually explained according to a single set of scientific laws. That is sometimes called the grand unified theory, which is like the major goal of contemporary science. Grand unified theory sometimes is abbreviated GUT, for the obvious reason. So what science hopes to do and what it assumes that it will eventually do is generate a set of scientific principles and laws that can explain everything in reality, from the biggest large scale phenomena down to the smallest tiny quantum phenomena. But right now, we haven't quite got there because we use the theory of general and special relativity from Einstein to describe the behavior of large scale macroscopic reality. But then at the tiny little nanoscales, we have quantum physics to explain the behavior at that scale. And there are actually discrepancies and contradictions between quantum theory and the theory of relativity. So the kind of goal of science in the 21st century would be to somehow build a bridge between these two realms, quantum and relativistic. Well, will we get there? We're not sure, but it is at least an ambition that science holds. And science does assume, anyway, that it should be possible for there to be a single set of scientific laws or principles because it's one universe. So why should there be different laws that govern the behavior of the small things as opposed to the large things? We haven't got there yet, but that's another assumption science has, that we will and can eventually get to a unified theory of reality. Yeah, I don't know if Gödel disproved that there's a possibility for integrating relativity and quantum physics. I think his work was more about undecidable statements within formal systems. Um, so, I mean, in a way, his work is a little more based on like pure logic and and notation. Some people disagree whether or not it has a deep implication about the structure of reality itself, like is reality an undecidable system? Formal systems are undecidable, like mathematical systems and logical languages. But does this graft onto physical reality? That's where maybe a more metaphysically minded uh, commentator of Gödel would be willing to extend his results. But I don't know if he himself saw his work as having implications about the structure of reality itself. But it's something that has been debated. Yes. Okay. So next, I just want to talk to you guys briefly about what are some limitations of science. Limitations of science, really quick here. No, I mean, you're kind of right, Gabriel, that, the formal systems do in some cases exist to describe reality. But I've dealt with a lot of technical people, and some of them in the most technical research fields, they don't like the philosophical assumptions that are associated with the formal work, even though the philosopher and the common person understand that that's probably what it is all about. So you get into academic disputes here that are kind of hard to fully resolve. But yeah, some limitations of science. So one of them is simply this. Okay, so one of the limitations that is mentioned in our book is this one that kind of gets back to our Descartes discussions. Science does assume that the external world is real, objective, and it's out there for us to discover facts about, and that cannot be absolutely proven. So, are you living right now in a simulation? Is this just a dream that you're having? You don't think so, and neither does science. But I guess we couldn't absolutely prove that because suppose for the moment that you were in a simulation. If it was a very, very good simulation, then the simulation would be just like reality. And so you couldn't tell the difference between it and reality, especially if you've always been in the simulation, then you'd have nothing to compare it with. So science doesn't think that we're living in a simulation or some type of big dream. They think that you're immersed in a real physical environment with other minds and with all kinds of objects, and that they can be discovered using reason and the tools of observation. Um, because if there was not an external world, then there would be no point to doing science, because anything you discovered about the world would be discovering something about the simulation, which is not even real. So, like, imagine that Mario from the Mario Brothers wanted to start doing scientific experiments on the magic mushrooms in the, Mario Kingdom to see how they work. It would be a pointless exercise because he's learning about things that are not even real because his whole universe is a video game universe. So anyway, we assume that you're not right now like a character in some kind of simulation. Um, if science was all based on learning things within the case of a simulation, then there would be no point to any of the knowledge, and therefore we assume that's not the case. But we're limited because we can't prove absolutely that this assumption is true. Nonetheless, I don't think anybody except for maybe the most esoteric-minded skeptical philosophers would find much trouble with this given assumption. Um, is there any evidence for unity, Gabriel? I guess it's sort of like a postulate of reason. One universe, one set of facts, one set of laws. It's not elegant, is it? It's not parsimonious for there to be two distinct sets of laws for one universe. And what would be the boundary between the smaller and the larger scales of description? It would seem to be a gray area. That's about as much as I think I could say to give you a sense of the answer to your question. GUT, Kelvin, is grand unified theory. It's the idea of a theory that could build a bridge between describing little quantum particles and then big macro scale reality. In the scientific field right now, we have quantum physics to describe the little tiny things, and we have the theory of relativity to describe the big things, but the two fields are not consistent with one another. So the grand unified theory is the idea of a theory that is fully consistent, which can describe both the small and the big. Right now, we have two different fields of explanation, quantum for small, relativity for big. And we hope and believe, science does, that eventually it will be possible to have one unified set of laws, not two, that can describe everything from the biggest to the smallest and stop having to sort of like break away from one field to another, depending on whether we're talking about quantum particles or large phenomena. I hope that makes some better sense to you, Kelvin, but you can review the lecture again too if you want. It's not the hugest deal to get on all the details clear on it, but I'll read from the book and you can see exactly what the book says. On unity, it says, associated with the belief in predictability is the assumption that there is an underlying unity of the universe, a unified dynamic structure that is present in all phenomena. These unified structures can be translated into scientific laws that are universally applicable. Albert Einstein devoted considerable effort during his lifetime in search of a grand unified theory, but it has so far been unfruitful. Okay, good. Now, one limitation of science, as I mentioned, is that it assumes the existence of the external world, which can't be totally proven. Another assumption, which is a limitation kind of, is that science can only study that which is observable. Science can only study that which is observable. If there's anything that's not observable, then it would be something that's forever outside the scope of scientific understanding. So, I mean, if, for example, there were supernatural phenomena in this universe, like ghosts, souls, spirits, divine beings, or something like that, if there were such things, then if they're not observable, science could never understand them or study them. So maybe you could see this as a limit if you think there are a lot of unobservable things. Even outside the realm of the supernatural and the occult, there are even scientific concepts of things that are not observable. For example, it's been noted that the universe is expanding rapidly outward, and all matter seems to be becoming less dense. So basically, everything's expanding outward from perhaps a central point when we had the Big Bang. But the Big Bang and the forces itself that project all the matter outward is not enough to explain why the current acceleration rate continues to increase. So scientists haven't been fully able to understand the basis for this outward expansion of all matter and why it's speeding up. But one hypothesis is that it has to do with dark matter, and that somehow properties of dark matter fuel the outward expansion of everything else. But dark matter is called dark because there's no way to directly or indirectly observe it. So it's one of those things that's going to be hard for scientists to fully formulate theories about, since it's not capable of, observation. So maybe this is another limitation of science, the fact that if things are outside the scope of what's observable, then science can't really deal with them very well, if they even exist. Um, does it have any impact on anything in the universe? Well, I mean, that's the thing. It would be very hard. I guess the only way you could judge it is if it has an effect on other things that are directly observable. Before we knew necessarily that there were like before we had electron microscopes, we were able to speculate and, well, not speculate, but theorize that there were atoms, and we could observe their behavior on other things in like cloud chambers and such. But that's a little different than dark matter, so it's just a vexing question, really. We do see the universe expanding, but the cause of it is still something that can be debated, and different hypotheses can be generated for it. The dark matter hypothesis is one, but the connection between that hypothesis and the correct explanation for the phenomena is not tight enough for us to say that we know that that's what's causing it. But no, those are good questions too. One more limitation of science, and I'll just talk about it in passing. Some people critique the predictability assumption, and for reasons that I think I kind of mentioned in passing earlier. Predictability assumes that the universe is orderly and predictable, so the natural laws and the cause-effect relations will always stay stable and never change. But you could say that that's a limitation because, again, we don't know yet what the future will be like. All we have is a partial view of what has happened so far. But I guess that's kind of like a criticism of induction itself, which is something that some philosophers, David Hume and others, have said. You can never guarantee that the inductive conclusion is true. You just have some, at least a finite degree of evidence that it's going to happen that way based on your observations. Okay, now the next part of chapter 12 talks about 4 views about the relationship of science and religion. So much has been said about an apparent conflict, or tension at least, between these two realms, science and religious. So what are the views that could explain the attitude about that connection? 4 views about the relationship of science and religion. So I'm just going to list the views first, and then we'll go over them one by one. So the first of the 4 is that science takes priority over religion when the two conflict, when they come into conflict. Okay, so that's one view, kind of like the view of the scientific realist. A second view is just the opposite, which is that religion takes priority over science. When the two conflict. Okay, so that would be like the more devout religious adherents' view about how to deal with these supposed conflicts. Prioritize religion over science if they don't agree. A third view is an interesting way to try and keep them separate. So the third possible view is that science and religion deal with different topics. So that means they don't really have a conflict. Okay. Then the fourth view at the end is trying to say that maybe they actually agree and they're compatible if you somehow interpret maybe the religious writings in a given way. So 4 is that religion and science are compatible. Okay. So let me just speak about these a little bit. The first view there, that science takes priority over religion when the two conflict. So there are definitely certain claims that science and religion at least seem to not take the same view. They don't see eye to eye. Okay, so just to list a few. Does prayer change anything or do anything? Science says no. Religion says yes. Did God create the universe in 7 days and on the seventh day he rested? Or did it take billions of years for planets to form and even longer for life to form, including human beings at the tail end of universal history? That seems to be a difference. Religion saying that it all happened within a week, science saying that it took billions of years. Uh, is evolution true or is creationism true? Were we created in the image of God, or did we descend from great apes and primates over a long train of evolutionary timescales? Um, well, this one's been settled, I guess, but prior to this, in the past, it was wondered, is the Earth the center of the universe, or is the sun the center of our local cosmos? Um, Now, in all these different cases, we can see religion and science not having the same viewpoint. And if you follow the first view, then in light of these conflicts, you would take the scientific answer. So if creationism and evolution don't agree, if you hold view number one, you're going to say, well, I believe in evolution then. Or you're going to say that I think that the universe was not created in 7 days, but that it did take billions of years, or whatever the case may be. So that's a view that someone would hold if they wanted to dismiss religion when it came into conflict with scientific conclusions. The second view is the opposite. So this would be like a person who says, when science and religion don't agree, I'm going to go in favor of the religious claim. So, if there's a religion that says the Earth is a couple thousand years old, but we have fossilized remains of dinosaurs and things that say they're millions of years old, then the person holding view number two would say science must be wrong. The scientific community must be wrong or misinformed or worse, because the religion claim is true by contrast with the scientific one. So creationism is true. God did create the universe in 7 days. Prayer works, all stuff like that. That would be your view if you're a person that holds number two. The third one is to try and create like different lanes for these two different fields, so they're not even overstepping each other's boundaries. So you might say that science is all about, a physical description of reality and how cause and effect processes work in nature. But religion is about a spiritual reality and a moral side of life, like values, what's good and bad, how ought I to live. Um, so if you try to cordon them off and they're their own separate domains, you might say there's no room for conflict because they're just not even talking about the same stuff. One is about spiritual life, and the other is about, physical reality and how things work. But although that's an option, I think it's a little hard to sustain because it at least does seem to be the case that religion and science have common interests and topics. Like science wants to talk about the origins of man, the origins of the universe. So does religion. Um, so it's hard to say that they deal with completely different topics when there does seem to be some overlap in the nature of what's discussed, but that's okay. And then the fourth view would be to say that religion and science are somehow compatible with each other, meaning that, I don't know, if you relax your interpretation of perhaps literal biblical doctrines, then they can come into alignment with the scientific conclusions. So maybe somebody might do this. Have you ever heard someone say this? So like, I'm trying to finesse the two things so that they don't disagree. Um, the Bible says that it was 7 days, and that Gabriel, you're already on top of it. So days didn't exist before the sun, so everything was created before the seventh day, right? So a day could be like an arbitrary unit of time, like a day in the life of God could be an unimaginable span of, the time scale. And day doesn't literally mean 24-hour day. So now there's no disagreement between the two. Or maybe what about evolution and creationism? Well, what God did was he created us in his image, but he wanted to use the process of evolution to get us there. So he had an end goal, and he allowed the natural processes to play out so that we would inevitably be generated in the image of God. So there's ways to try and diffuse the appearance of conflict between the two realms. But the only problem with number four is that it can seem to be like ad hoc reasoning, just after the fact. You assign this as the correct explanation. But it's only because the scientific community has put pressure on the religious claims that these revisions are ever given. Nobody ever says to change the literal interpretation prior to the scientific discovery. So it may just look as though after the fact, someone tries to reconstruct the interpretation so that it falls into alignment with whatever the scientists happen to be discovering. I'm not sure about the sponge argument you're referring to, Gabriel, but maybe you'll have more to say about it, and I'll have some sense of it. But yeah, like, so about religion and science being compatible, I'll just give you this one little metaphor that I sometimes think is helpful to explain the point. Suppose that you fired an arrow at the side of a barn, right? And just not aiming at anything, just, it's going to hit the side of the barn somewhere. So you hit the barn with the arrow, and then you walk over to wherever it landed, and you draw a bullseye around the landing point. Now, that doesn't mean that you're an expert marksman, because it's not like you were aiming for a bullseye and you hit the target. You just hit wherever, and now you draw a target around the landing place. I kind of sometimes think that this is how one might criticize the attempts to modify religious doctrine to bring it into alignment with science, because it's only after the scientific conclusions are presented to the world that people then think maybe we should revise our current day understanding of these religious statements. So it's not like anybody had the intention to change them prior to the scientific community producing new results. Therefore, it could also seem to be somewhat arbitrary, ad hoc, and ex post facto justification. After the fact, we justify why it's actually saying the same thing. Okay, now there's more in chapter 12, obviously, but this is a good breaking point because we're running low on our day's time. When we come back on Thursday, we'll talk about the scientific method. We'll talk about the steps that it has. We'll also talk about what are some assumptions that are built into, not assumptions, sorry, we did that today, rather qualities of a good scientific theory or hypothesis. And then we'll also briefly talk about pseudoscience and how it's different from like real valid scientific research. Now, Gabriel, you say, isn't that the right thing to do, though? If you make a false prediction, you change your theory to account for that contradiction. No, don't you just get rid of the theory because you think it was wrong? You're not supposed to have a cherished theory. You're trying to get to the truth. So, like, if my theory that, some phenomenon is invalidated by experimental results, you're supposed to generate a new theory. You're not supposed to tweak the experiment until you get findings that are consistent with your hypothesis, because your hypothesis is tentative. It's not known to be true until it's put to the test. So I wouldn't agree with that, actually. You don't change hypotheses to account for disconfirmation. You get rid of the hypothesis and replace it with something else. Changing it means that you're never going to give up on it, no matter what the evidence shows, which would be unscientific, because the scientist is supposed to be willing to disclaim the hypothesis upon inconsistent experimental results. Yeah, so an alternative hypothesis is what I was suggesting. And it's going to be accepted or rejected rather by the results of the experiment. So it's not supposed to be like the subjective desire for your hypothesis to be true is what dominates your theoretical research. But okay, there's more to say, and we will expand on this more on Thursday too. So for now, though, I guess I will have to let you guys go. So I'm going to close the two streams one by one, starting with the Zoom and then with YouTube. But I'll see you guys on Thursday. If you need anything between now and then, as always, feel free to contact me by email. I'll post this lecture later to our page, and I'll send off the link for Thursday as well later tonight. So thanks, everybody. Take it easy, stay safe, and I'll see you then soon. And be in touch. Okay. Have a good one then. Bye-bye. Okay, so we're done with the Zoom. And if you're still here on YouTube, let me just close this one too. So have a great day, everybody, and I'll be in touch. Bye-bye.